Hello, Internet, and thank you very much for tuning into the Cloud Native Islamabad YouTube channel. And today we're learning about all things, all things on container technologies. Docker is a very powerful technology that can be used to package, deploy, and run your application anywhere. And in this workshop, getting started with good Docker, you will learn how an application can be run using Docker containers. First, you will learn how to take an application all the way from source code to a running container. Next, you will discover the role of Docker images and how you can build your own custom application images using Dockerfile and Docker commands. And let me introduce my guest today. He is from Docker, Michael Irwin. Thank you very much. Mike, are you in mute?
There we go. Thanks for having me. I'm
Yes.
excited to be here.
Yes. So thank you very much. We have a very good audience. I think on the internet should being watching this live stream. So first, first to tell us about your journey into the Docker so far container, how long you've been there, and why you think this is going to be a very wonderful way to talk about Docker.
Sure. Yeah. So my journey with containers has been over many years. It started 6, maybe 7 years ago, in which I was working on a new software development team, and we are trying to figure out how we can have a QA environment that supported basically ephemeral environments. We wanted each of our feature branches to have its own deployment environment, and we had tried a lot of really hacky things beforehand. And then someone was like, "Hey, you should try out these containers," and we're like, all right, and it just like was magic, and it just solved our problems. And then ever since then, I've just been really passionate about this space and how we can use Docker and DevOps and all these different tools to basically make our development processes and practices easier, smoother, better, to help us just kind of focus on app building. And that's really exciting. So yeah, I've been a meetup organizer. I was a Docker captain for 5 years, and so been in the speaking circuit, and it's been a lot of fun presenting and teaching people. I teach a class at Virginia Tech, a university here in the state of Virginia in the U.S., and I just love teaching and helping people out. And back in March, I joined Docker, and I'm now an engineering manager with the customer success team there as well, and trying to figure out how do we make it even easier for people to onboard and get going with Docker. So super exciting.
Yes, absolutely, absolutely. And you're the Docker Captain number two to being on in this YouTube channel. So thank you
Hurrah!
very much on the show. Yes. So previously we Billy on that Brett Fashion on my podcast,
Mm.
and he's telling about all the 7 years of Docker container journey, and you've been the second one. So if you want to share your screen, so we can start the proceeding.
Absolutely. Yep. I'll get this up here, and we will dive right on in. All right.
Yes, absolutely. So I can see your screen. So I will be background managing the activities. Now you can start the proceeding.
All right. Thank you. All right. So we've got a lot of different things that we're wanting to go over. So as a quick agenda, here are the things that we're gonna work on. And I've got the times in two different time zones. One because I'm East Coast US, and it helps me map and keep myself on schedule. So we're going to start a couple minutes ahead, and this will give us a chance to do more demos and have some more fun. So we're going to start off with a intro of Docker and containers, and why containers, and provide a little bit of background there. And then we're going to talk about container registries and images. We're going to build an application, and then later on, we're going to talk about Docker Compose and how it allows us to support multi-service applications. And once you start doing multi-service, you got to figure out how do I network these applications together. So we'll talk about some networking as well. And then finally, we'll kind of wrap it up and kind of kick things off for next discussions and next steps. Talking orchestration, Kubernetes, and all that kind of stuff. So to set expectations, we're not going to talk about Kubernetes here. It's going to be really just about the local containers and development experience, et cetera. To help us better understand what are containers and all that kind of stuff too. So if you've got questions that come up along the way, feel free to drop them in chat, and I'll be happy to respond to them as we're going through, and we'll just have a good time together. So we will make all the slides and the content available for you afterwards. So feel free to just sit back and enjoy, and go through it yourself later on if you want to as well. All right. So first off, intro of Docker and containers. What is what is a container, and what is it that we're trying to accomplish here. The easiest way to explain containers is by using an analogy. Okay, so a long time ago, if I were a goods producer, and so I made any sort of goods, if I wanted to ship them to another market, I had to find a way to ship them. And so what I would do is I would find bags, barrels, crates, boxes, whatever else I could find, and I would shove my goods in there and I'd haul them down to the nearest dock. And then the dock hands there would take those bags, barrels, and crates and load them into the ship. And it was a very manual and arduous process. And in fact, and I've got it here on the slide deck as well, the second bullet here, ships spent more time at dock loading and unloading than they did actually out to sea moving the goods around. And that's because you had to kind of play a Tetris game and shove as much as everything you could into the ship. And it just took a lot of time. And because so many hands were touching everything, oops, a bag gets ripped, I can pocket the goods and, I made a little extra money today working the docks. So it's obviously not the best environment here. When the Industrial Revolution came along, much of the same practices existed. As a goods producer, I would find bags, barrels, crates, boxes, whatever, and I would take them down to the rail yard. But one of the challenges then was, okay, I would move my goods, or my goods would be moved from one rail car to another, and maybe even onto a ship to go across the sea. And so all the inadequacies of this load and unload process, they were amplified and they were really compounded, and people really started to notice them. And so we needed a better shipping practice. And it wasn't actually until about the 1950s that somebody's like, why don't we just standardize around a box? And that box became the shipping containers. And with the shipping container, what it allows the shipping industry to do is standardize around a box. That the shipping industry doesn't need to adjust between bags, barrels, and crates. If I still want to pack things in bags, barrels, and crates, I can do so, and I can just shove them into one of these shipping containers. And again, the rest of the industry can focus around that and be able to know I can have cranes that can lift them off of the ship and put them onto a truck chassis or onto a rail car chassis, etc. And it just allowed the throughput of these containers to just go through the roof. And again, since the individual goods, the bags, barrels, crates, etc., weren't being touched as much, the chance of loss and theft plummeted. And it's much harder to steal things when, for the most part, you're never going inside the container. And one other thing to mention too is now it allows higher level abstractions and tooling and automation to be built out. Okay, so with this in mind, with software, we're going through very much the same evolution, where in the past, we ship software around, and whether I was a Node app or a PHP app or a Java app or whatever, every application was deployed differently, just like every good was produced and put into a bag, barrel, or crate a little bit differently. So the question is, how do we standardize that? And that's where containers have come in. Okay, so what actually is a container? And we'll do some demos here in just a second. One of the things I want to make really clear from the start is a container is just an isolated process. Okay, there are a lot of people that compare containers to virtual machines, and it may help people kind of understand or kind of enter the space if that's the mindset that they have, if they're coming from a virtual machine world. But the way to think about it really is that, again, a container, when it's running, is just an isolated process. Okay, and it leverages something called namespace to provide that isolation. And again, we'll see an example of this here in just a second. We'll dive in a little bit here. Okay, but one of the neat things about containers is that when they're running, and when we package and create containers, just like with the shipping container, we put everything that we need inside of that container. So with a software container, we put all the binaries and config and source code and dependencies, and everything that's needed to run an application is bundled within this container. And the goal here is that if I build a container on my local machine, it'll work the exact same way if I run it on a remote machine. And that's really the goal here. We want to be able to know that the code that I wrote will run the same way in my CI systems, in my pre-production or staging environments, and in my production environments or any other QA environments. It should run the same everywhere. Okay. Now, enough talk, enough slides. Let's dive in and do some demos here. So I'm going to pull up my terminal here because we're just going to play in the terminal a little bit. And what I'm going to do first is I'm going to run a Ubuntu container. And the -ti flags basically run interactive and put my current shell inside the container. So I press enter here, and now I'm inside of a Ubuntu container. Okay, and if I look at the files that are here, I can see quite a few different files. Pretty cool. Now, one of the things I'm going to do is I'm going to run the sleep command for 60 seconds, and I'll throw the ampersand here to throw it into the background. Okay, and if I list out all my processes, I see I've got the sleep process looks like it's process ID number 10. Okay. That seems like a pretty low number, and trust me, it is. We also see that process ID 1 is my bash. Okay. And if you've done any sort of, working with Ubuntu machines, process ID 1 is not bash on a normal VM. Okay. So I'm going to now go split screen here, and I'm going to connect into the actual my actual VM here. So Docker, when it's running on my local machine, runs in a VM. And what I'm going to do is, so I'm on the host now. I'm going to list out all the processes. I'm going to grep and basically filter for that sleep. And so I see the same sleep process that I ran earlier. Okay. But instead on the host, it sees that it's process ID 2808 or 890. So I've got a different process ID going on here. And this is an example of the process namespace in effect. What happens is that when the container's running, it can only see the processes that it spawned. Okay. As another little demo here, if I run the same command, Ubuntu, and let's just do another sleep over here. I know this is word wrapping quite a bit here, but the sleep over here is now process ID 9. Let's see if our sleep is still going here. Oh, it finished. Just do another one. And I can see that, I've got another sleep, but, both of these containers can't see each other's processes. So they're, again, isolated off from each other. And on the host, I can see both of those sleeps going. Now, of course, this is a pretty simple use case here, in which I'm just running a sleep. But the same thing works for applications where if I have an Nginx server, a PHP app, or a Node app, or Java app, or whatever, it can only see the processes that it spawned. Now, there are a lot of other namespaces that exist as well. One of them is, let's see, not installed right now, and that's okay, is the network namespace. So every container gets its own IP address. And because of that, it can listen to its own ports. I can run, for example, let's back out of here. Docker run, I'll throw it in the background, Nginx Alpine. And I'll run another Alpine, I'll run another Alpine, and I can run, for Nginx containers here, they're all listening on port 80, but since they all have their own network namespace, they're all port 80 of different IP addresses. And, we'll talk a little bit more about networking in a little bit. Now, before we move on, I'm going to go ahead and remove these. As a quick tip, do a Docker PS here. If you want to remove containers, I'm going to do remove and -f, so it'll both stop it and then remove it. You don't have to copy and paste the full ID here. So I can just do FD8, 607. I can even do 3F, DC. I can do partial IDs, and as long as they're unique enough, if this doesn't match a single, or I meant to do 60 there, it'll remove the container. And so now I don't have any containers running. So there's a little quick tip there for you. So again, a container is simply just an isolated process that's running on the machine and allows me to kind of package up an application and let it run in isolation from other applications. Okay. Now let's jump back to my slides here. All right, and we'll keep going. So we're a little ahead of schedule, but that's okay. It'll give us more time to do some building an application a little bit later. Okay, so let's talk about how we build these container images. Okay, so in order to build a container image, we need to, again, going back to the shipping analogy, we need to form this box. Okay, and the way that we form the box is there's a couple different ways, but the preferred way is to use something called a Docker file. And the Docker file defines a text-based script to build your image. Okay, And since it's a file, that means that it can be version controlled. It can be included in your source code repository, et cetera. And I would highly, highly, highly recommend you doing that to keep your Docker file with your application. Within a Docker file, there are a lot of instructions that are available. And let me grab the laser pointer here. Okay. Typically, a Docker file, the very first command is going to be a from, and this is going to be the base image that we're going to start from. And as we run additional commands, we're going to be adding more and more layers to our image. And kind of, again, think of it as rather than start from scratch, we're going to get a shipping container that already knows how to start with Node or start with Ruby or whatever. We can have a base image that already has a lot of things installed with it. And then we can start adding layers on top of that. And we'll see that here in just a minute. So I'm going to do my from. I'm going to copy I can copy files from my host and put them inside the container image into specific spots in the file system there. I can run commands inside the image. So if I need to install other packages or whatnot, we can run commands. And then the CMD, which stands for command, allows me to specify the default command that I'm going to execute whenever this container image is being used. Now I can override that command when I start a container. So again, it's just a default. Okay. Now for this, what we're going to do is I'm going to build a basically an example MERN stack. Okay. And if you don't know what a MERN stack is, that's okay. In fact, let's go ahead and jump over here and I will drop this in the YouTube chat. Okay, so there's that in the chat. And what this repo is it's an example MERN app. If you don't know what MERN is, MERN stands for Mongo, Express, React, Node. Okay. And so what it does is it uses Express and Node for the back end, and then the front end is a React application. And there's a lot of examples out there. This particular application, what we're going to do is this starts off as a non-containerized application. So in many ways, it's representative of a lot of the GitHub repos that I saw out there, and I just made my own for this workshop here. And what we're going to do is we're going to containerize it, and then as we go throughout this workshop, we will turn it into a compose stack and add a compose file to it, and we'll just make it a much more fun development environment here. Okay. And with a lot of MERN stacks, what happens is that in order to do development, first I need to install and run Mongo. Okay, so I'll have to install Mongo and I'll have to start it up, and so that way my application can connect to it and run and use it for persistence. Then I had to install the dependencies and start my back end, and then my front end, kind of same thing. I need to install the dependencies and then start up my application. And then when I deploy it, I can build my front end and kind of combine it together and then go from there. Now, what makes this a little tricky, though, is that this makes assumptions that the developer has to have all these things installed and configured on their machine. So they have to have Node, they have to have Mongo. They then also have to use different ports for the front end and back end. And maybe we've got time. We'll talk about how to put a reverse proxy in to make this even a little bit easier. We'll see what we can get to. But we want to make this developer experience as simple as possible. For myself, I'm a big believer in I should be able to git clone, Docker compose up, and be able to start contributing to a repo. So we're going to basically convert this repo to do that. Now, so I've already cloned this repo locally, and what we're going to do is jump into VS Code. And we're going to start off by first making a Docker file. And this Docker file is going to be used to just build the application. And, maybe actually first, let's go ahead and run the app first, just so we can see what we're working with. So I'm going to follow the instructions. Instead of, I don't have Mongo installed on my local machine, so I'm going to run Mongo myself just in a container. Mongo uses port 27017, and so I'm just going to expose that. And so now if I follow the instructions that were in the README, I'd go into the back end and I'd run yarn install. And then I would run yarn dev. Okay, and so now it's got the application up and running. And now I need to do the same thing for the back end. Yarn install. It take a second because it's a React app and it takes a while to set up everything, but all right. And then I run yarn start. This will take a second to kick off the development server. And once it does so, then in my browser, I'll switch to that now. It's basically a to-do list application. And so I can add items here and say, item number 1, item number 2, be awesome, do a great job with the workshop, whatever to-do list items I want to do. And I can mark items as complete, and I can delete them. And what I'd see is if I inspect the network, network tab, as I'm completing the items, I'm seeing put requests being made to update the backend, and those are going to localhost 4000. And so as delete items, I should see a delete request show up here, which I do, and whatnot. So again, this is our sample application, and we're gonna containerize it here. All right, so let's jump back to VS Code, and we're going to start off by creating a Docker file. Now, as I mentioned earlier, a Docker file typically starts off with, what are we starting from? Very rarely will you ever start from scratch. So there is a way to say, hey, just give me an empty shipping container and an empty box, and I'm going to start from scratch. And it's literally called from scratch. But that's pretty rare. I would say some of the good examples I see of that are going to be around using like Golang apps where the binary is fully self-contained and whatnot. But so you do see that there, but then you run the risk of, if you need a debug or you need to get into the container and take a look at things. Well, now what's your shell? What are your the commands you expect to be there? They're not going to be there. So be careful with using from scratch. Okay, so what we're going to do is, since this is a Node app, I'm going to start with Node LTS Alpine. And this is a common base that I use quite a bit. I know there's a lot of talks out there. Brett Fisher actually just did a good one at DockerCon about kind of picking a good base image and whatnot. But I like using the Docker official images. And because of that, I'm going to use the LTS, which stands for long-term support, and the Alpine variant of that. Now, in order to start actually building my application, I need to, again, think of this as just a Node container image. So I need to start putting in my dependencies, my source code, and that kind of stuff. So the first thing I want to do is actually specify a work directory. And what this is going to do is basically say, this is where in the container image I want to be working. Now, I'm going to start off with a fairly naive approach, in which I'm going to say, let's focus on the React app first. Okay, so I'm going to copy client, which is the client directory, which has all my source code in here. I'm going to copy it directly into the container. Okay, so this is going to copy my source public node modules build, everything that I have here. Now, one of the things that we may notice here is that I may not want to copy my node modules in, because first off, if I just git clone this, I may not have them yet. And second of all, they may have different architectures. The node modules that get installed on my Mac may be a little bit different than what I need inside of a container. So what I actually want to do is I'm going to make a Docker ignore file here, which I say I don't want to copy in any folders. And the structure here is just like a git ignore file. So I don't want to copy in any node modules or any build directories. Okay. And then from here, let's run yarn install to install our dependencies, and then let's do a yarn build. Okay. And let's just take a look at this real quick. Now, there's a couple of you that may already be watching this and like, there's some better ways of doing this. And you are right. We'll get there in just a second. Okay. So let's go ahead and build this real quick. So I'm going to build, and I'm going to tag this with the -t. So this gives a name to the image. I'm just going to call this MERN app. Okay. And then the dot is the current directory. So we'll use the Docker file in the current directory, and it's going to ship everything off. It starts to build. We see it copy the client directory in. It's running the yarn install. This will take a minute because it's got to fetch a lot of dependencies and everything. Maybe I should have started with the back end first, but that's all right. All right, so we see it doing its thing now. All right, so it's fetched everything, and now it's going to do the build. And as it does the build here, so it took about 30 seconds to do the install there. Exporting layers, so our image is almost done. We've written our image, and hooray. Okay, so now at this point, if I were to run that container, burn app, and I'm just going to run a shell to put me inside of that. If I look in this container image, I'll see that I've got a build directory. And if I look in the build directory, I see all of our compiled React code. So there's our index.html. I've got all of the resources in the static directory. So hooray, the build worked. Now I'm going to try something here, and let's see what happens. So if I go into my client now, and let's just tweak something here. Maybe let's just add an extra space here, just an enter. Okay. And now let's rebuild my image here. Now what happens is you'll see that it's doing the yarn install again. And it's like, all I did was add a space here. Wait, what's going on here? So let's first off, let's stop that so we don't have to re-download the internet here. What's happening is that when Docker images are built, it tries to leverage caching as much as possible. So again, think of this as we're building, we're adding layers to our application. And if I look at the history of this, I can see that this is the node LTS Alpine image. I specify my worker, and again, think of this as layers going on building on top of previous layers. I copied in my client directory. I run the yarn install. Okay, that added 337 megabytes. That's quite a bit there. And then I did my yarn build. But so in order to effectively use caching, what happens is that when the build occurs, once one layer gets invalidated or once one layer changes, it has to rebuild all subsequent layers. So when I look at this, I'm copying and saying, hey, I want to copy all my client code and put it into my application or my container image. Well, since I changed a file, I just added some spaces in it. That invalidates this layer. And now all the subsequent layers have to be rebuilt. Okay. So a best practice here is when you're defining your dependencies, separate those from your app source code. And what I mean by that is something like this. So I would copy just the package.json and the yarn lock files in, and then I would do my yarn install. So in this case, the only things I'm copying in are my package.json and my yarn lock file. And I just noticed I have a package lock JSON. So I guess at one point I did an npm install. So my bad there. Anyways, so I just copied these in, and now I only have to run the yarn install anytime that my package JSON changes, so for example, one of my dependencies change or something else, in that case, I do want to run my full yarn install. Okay. And allows subsequent builds to be much faster. And we'll see that here in just a second. Let's go ahead and copy in the rest of our source code then. So I'm going to copy client public, put that into the container, client source, put that in my container, and then I'll actually run my yarn build. Okay, so I'm going to save this, and let's go ahead and run the build again. This will still take a little bit of time. Actually, since I did this not long ago to prep for the workshop, you see that it was able to reuse the cache layers from a previous build. And so it didn't have to do the yarn install at all because I had done it earlier in preparation. And so the build of this image now is 15-ish seconds rather than what it was before. Okay. And now if I do my image history for NAP, see that, and okay, some of these are from a little while ago when I was prepping for the workshop. But I'm getting more advantage out of my caching, and now my build times are much faster because of this. Okay. Now, so at this point, I've got my client code built. Okay. So let's just put a comment here of build React code or React app. Now, in order to ship this application, the README stated here that in order to deploy it, I have to build the front end, and then I copy the artifacts from the front end build directory, and then I put them into the backend source static directory, where the backend will actually serve it. So even though the code base is in two separate directories, I can ship it as a single application. And then from there, I can just copy the entire backend directory and go from there. In case you're wondering, we can dive into that. So the Express app is saying I'm going to serve all the static resources in the static directory. Okay, so what we want to basically do is take this React code and put it into the source static directory. Okay. Now, what's cool is we can leverage a feature in Docker called multi-stage builds to do this. Okay. So what I'm going to do again is we've got one image, one stage that's going to build our React app, and then we've got another stage that's going to be our backend. So we still need to build our backend. We need to install the dependencies and whatnot. But once we've done that, then we want to copy the output of this, that build directory, and put it into our backend container. Okay, so let's make another one. Set up and build the backend. Okay. In this case, I'm going to start also from node LTS Alpine. So just so we're using the same version. And I'm also going to say workdir user local app. We'll talk about a way that we can even further optimize that here in just a minute. And now I'm going to basically do the same thing that I did up here. Which instead of copy from client, now we're going to copy from backend. And now I get my package.json and my yarn lock, and I run the yarn install. So again, as the instructions were kind of saying, in order to deploy this, I want to copy the contents of this build directory that had the index.html, all those different pieces, and I want to put them into the source static directory, which isn't here right now. Okay, so what I can do is I can say I want to copy from another stage. So let's see, we need to name this stage. Maybe we name it React build. And I want to copy user local app build and put it here to user local app source static. And actually, before I do that, I need to copy all the backend code in place too. So backend source. All right. And now we need to actually name this other stage. Okay. All right. I know there's a lot of moving pieces here. Okay. So let's recap here. So I've defined a stage here, and a stage is simply a set of instructions that follow a from. Okay, so I've got a from, and this defines a stage. Once I specify another from, this is another stage. And I can name a stage by using the as React build, which allows me to say I want to copy from a previous stage, and this is the source in that stage, and this is where I want to put it inside of this stage. Okay, so I'm using containers to build other containers. Mind-blowing. It's awesome. Okay. And the last thing I need to do now is just say, let's specify a default command here. All right. Go ahead and build this. So now, since we didn't change anything on the React build, you see that it was able to reuse the cache from the build that we just did a few minutes ago. And all we had to do now was install the backend, copy in the source code, and go from there. So theoretically now, I should be able to run my application now. It does say in the README that my backend runs on port 4000. So I'm going to run my container on port 4000. Okay. And so now we run into an interesting problem here where it's saying, hey, I'm trying to connect to Mongo using localhost. And we'll talk a little bit more about networking here in just a minute, but my container is kind of stuck. Okay. Because as I hinted earlier, this network namespace that every container gets means that a a container has its own local host. And so it's trying to talk to Mongo within itself, and it can't connect. And eventually this is going to be a connection refuse. It says, hey, I can't connect to Mongo here. So since I had Mongo running on my local machine, what I can do is this application does let me specify an environment variable to change where the Mongo host is running. And I don't have that in the README, so I should probably update the README to reflect that. But what it allows me to do is I can specify an environment variable to say, instead of connecting to localhost, connect to somewhere else. Okay. And Docker Desktop allows me to, let me just pull the previous one. I can specify this environment variable and host.docker.internal. What this name maps to the IP address of the host machine. And when I click run here, what it will do is connect to the Mongo database that I had exposed on my machine. And this should work. There it goes. Okay, so connected successfully to Mongo using that host, and it's listed on port 4000. And so if I jump back to Chrome now, let's create a new tab, localhost 4000, get my application. And because it's connecting the same database that we saw that I was testing with earlier, now I see the items that I had left in there previously as well. So pretty cool stuff, and I can delete them, etc. So I've successfully containerized this application. Now, if we want to actually try this out, let's actually tag the image. So what this is going to do is that when I built the image, I gave it a name of Mernab. What tagging lets me do is basically give it another name. So I'm going to tag it with Michael Irwin. This is just my user name on Docker Hub right now. Sample Mernab. Okay, and now I'm going to push that. Actually, before I do that, one small little caveat here. Since I'm on a M1 MacBook Pro, the default architecture that it's building is using the ARM CPU. Okay, so if I want to run this on a machine that's got an Intel chip in it, I need to specify the platform. And the way that I do that is specify a platform of Linux AMD 64.
So, Arvind, sorry to interrupt you. Okay, you can you're sharing the wrong screen there.
Oops, my bad. Sorry about that, everybody. There we go. Okay, thanks for that. Okay. All right, so what I'm going to do now is when I do my Docker build, I'm going to tag it with my Docker Hub ID and the name of the image and Docker Hub, and I'm going to specify a platform that says, rather than building with the ARM CPU, I want to emulate and build it as an AMD 64 architecture. And what this will let me do then is I can run my application on Intel-based machines, which we'll do here in just a demo. Now, so it's going to have to run this build again, and this will take here just a second to install everything. And yeah, the emulation is pretty darn fast, but it's still emulation at the end of the day. So so let me explain a little bit of what we see going on here. With the Docker file, since this is a multi-stage image, it's trying to do as much in parallel as possible. So you'll see that it ran this stage to as far as it could, but once it hit a copy from another stage, it's blocked there, and it can't make progress until that stage is completed. And we see it doing that right now, where it's doing the yarn install. It's still going and fetching all those different dependencies for React there. And so once this stage is completed, then we can actually copy from the previous stage and continue going from there. So again, the builder tries to do as much in parallel as possible. So we'll sit here and wait for a moment and watch this go. All right, looks like our install is making progress and starting to wrap up a little bit. Seeing a couple hellos in chat come through. So hello, everybody. Thanks for joining us today. And again, if you've just joined us, if you've got questions or you want me to dive deeper onto any specific things, feel free to drop it in chat, and I'll be happy to explain something again, or maybe in another way, or whatever else too. So I know we're covering a lot of ground here, and some of this may not be Docker 101. Some of this may be the 201 level, but that's okay too. All right, so our yarn install is completed, and we've got a yarn build going there. Oh, I saw you pop up there for a second.
No, no, just it's going wonderful, wonderful. So I'll just saying like one thing like I really like about the Docker is it's Docker caching. Like it's
Yeah,
super awesome. Like
yeah,
when you build the image first time and next time you build the images, it's taking very small step. But many people doesn't know the fact that caching you have to set up to tell Docker to use that caching. And
yeah.
in a multi-stage Docker file, the way you've written it, I think that's telling the Docker you can use these build Docker caching to support my development time so faster. So I want you to just share some more details on Docker caching with multi-state Docker file.
Yeah, and so maybe I'll jump back a little bit to it. And so multi-stage lets me do a lot of really incredible things. Um, where I use it most is when I need different tooling to build an application versus run an application. And so, for example, a good example of this would be a Java application. So if I am going to build a Java application, in order to actually build my application, I need a JDK. I need to, maybe Maven or Gradle or Ant or whatever tools I need there. And then from there, I put in my source code, I compile everything, I get a jar file, war files, whatever my outputs are for my application. But in order to run my application, I don't need a JDK. And so if I don't need that, I don't want to bundle it in my final image, because then I've got to ship that JDK around. It's a potential vulnerability if somebody were to find a remote code execution type thing. And I don't want them to be able to compile more code on my production image. So multi-stage lets me separate those two. Um, and it allows me to kind of create a pipeline where in one stage I'll build and compile, and then the next stage I copy the artifact out of that and run it. And in much the same way that we're doing here, where in one stage I'm building my React app, and then my second one, well, I don't need all the React dev tools and Webpack and all those different things in my final image. I just need the final JavaScript, CSS, etc. And so it allows me to separate that. And so multi-stage makes that super easy, super nice. I see my build is completed here, but I'll finish up this thought. And since I can create the stages specific to the need, so in this case, this is a stage that's specific to build a React app, I can create the Docker file in a way that optimizes the caching that you were just talking about. So for example, how I optimize caching for a React app might look different than for example, my backend or whatnot. And so it allows me to have different stages for the different needs and still be able to leverage the image layering and the image caching going on there. So pretty cool stuff. Okay. Let's go ahead and push this image now. So this will take a second just to push everything. So what this is doing now is when I do a push, going back to my Docker file here, let's do the image history. And what we'll see is that we've see the build there, and it's having to push all these layers that aren't already on Docker Hub. Okay, so the base image, the Node LTS Alpine that I'm using, okay, right here, that's already on Docker Hub. That's where I got it from, and so it doesn't need to push that again. And so it only pushed the changes that we built. So the yarn install, there's actually ways that we can probably cut this in half, which I can show a tool off in just a minute on that. And it's having to push all this. So let's actually jump to our browser here, and I'm gonna just go to Docker Hub, and we'll see this is the image that we just pushed. Here's the tag, the latest tag, and it was built for the AMD 64 architecture. I can dive into the image, and I can see the exact same image history that I just saw on my local CLI. What we're gonna do from here is I'm gonna open up Play with Docker. If you haven't used Play with Docker, it's basically just a remote space that I could say, I want a container or I want a machine instance. And what this will do is give me a place to run Docker commands. but I use it a lot in demos because what allows me to do them, say, hey, this image that we just built, let's run it on a fresh machine somewhere. For example, if I try to type in node, it says, I don't know what node is, but I do know what Docker is. So I can run Docker and our application runs on port 4000. I'll paste in my image here and the Docker engine will say, I don't know what that thing is, but I'm going to go pull it from the registry. And now it's pulling down all the layers that I just pushed up from my local machine. And this is why I needed the AMD 64 architecture, because Play with Docker doesn't have a ARM-based instances. Okay, so now we see that it's attempting to connect the Mongo using host localhost. So it's the same problem that we had before. Okay, now we're going to pause on this, and we'll come back to it in just a minute when we talk about container networking. Okay, so we're going to let that fail, but then we'll talk about networking and loop back and fix this here in just a few minutes. Okay, so let me go back to VS Code. Maybe just a couple other things. And again, this is kind of getting into more of the advanced stuff, but I'll sprinkle a couple advanced things in here. One of the things that you'll see here is I've got this duplicated between the two different images. Okay. And if I wanted to make sure, or the two different stages, sorry, if I wanted to make sure that I'm using the same worker and the same base image, one of the things I can do is actually make yet another stage here from node LTS Alpine as base, user local app. And for these, I could say, instead of from node LTS Alpine, I can actually build on top of previous stages. So I can say from base. Now I don't need this there anymore. From base, and I don't need that anymore. So one of the advantages that this gives me is I update my base image in one spot, and now it's updated in both stages, which is pretty cool. So just a small little don't repeat yourself optimization there, but that's a pretty cool feature that I use quite a bit, where stages can actually build off of previous stages. So if you need common tools between different things, so for example, if I needed to do a if I need a curl, for example, in both of my images, I can do this as part of a base stage, and then each of these stages can leverage that. But anyways, quick little cool tip there for you. All right. Taking a look at chat. Any questions? I haven't seen any come through, but maybe I'll pause for a second and see if anybody's got a question that they want to ask before we move on to networking. And I guess when I say networking, we'll also talk a little bit more about Compose and how the Docker engine works and all that kind of stuff too. So.
Yes, absolutely. Go ahead. Like we're seeing in the chat, like we don't have any question, and people are just saying that's a very informative session. We are very good going. Go ahead.
Awesome. All right. Well, I'm okay with people just being happy and saying good things too. So, but yeah, feel free to ask questions along the way if anybody thinks of any, and we'll keep going. So, all right, Docker Compose and networking. Okay. Now, in order to talk about Docker Compose, and I'm actually going to talk, I'm going to flip the order of these a little bit. We're going to talk about networking. We're going to talk about networking, and we're going to talk about the Docker engine and the Docker engine API and how it all kind of supports tooling and whatnot. So this is going to get a little bit deep here, but hang with me and we'll make it through. Okay. So with container networking, now that I'll specify to this is specific to Docker networking. Okay, so this will look different than if you're doing networking in Kubernetes or service meshes or that kind of stuff. Every tool does networking a little bit differently. So again, this is specific to Docker. Okay, with Docker, think of networks as isolation boundaries. Okay, so if two containers on the same network, they can talk to each other. There's a network path between them, and we can use Docker inspect to view the a container's IP address. So for example, let me jump back to my terminal here. Wrong screen there. There we go. All right. Let's look at this Mongo container here. And I can do a Docker inspect with that container ID. And I can see its IP address is 172.17.02. And we can get that information there. Okay. So back to slides. I see a question came in, and I'll come to it in just a second. So we can use the Docker network command to manage networks. I can create a network, I can list the networks, I can inspect networks, and I can remove networks. There are also other commands to be able to attach containers to various networks, and you can do that even after a container is already running. Now, one of the things, again, that I talked about earlier is that when a container starts and a container is added to a network, everybody gets their own IP address. Okay. And so maybe let's actually do a quick little demo of this here. And we'll go back to my terminal here. And I'm going to run let's create a network first. And we'll call this workshop demo. Okay. And I'm going to start a container. So I'll run a Nginx container, but we're going to put it on the workshop demo network. And I spelled that wrong. -D will run it detached, so it runs it in the background. Nginx Alpine. Okay. So at this point, I've got the container running, and I can inspect 7631. I can see that it is on the workshop demo network, and it has an IP address of 172.18.02. Okay. All right, I'm going to go split screen here, and let's run a Ubuntu container. Actually, yeah, I'm going to run Alpine just because it installs things faster. APK add curl. So I'm going to install curl. And what I'm going to do is I'm going to try to curl that Nginx container. So I have the IP address for it. When I try to curl it, it just hangs. Okay. And that's because when I ran this Alpine container, I didn't specify the network. And so just put it into a default network that's called bridge. Now let's run the container and curl HTTP. So now now when I try to hit the Nginx endpoint, hey, look, now I get the Nginx, a welcome to Nginx page. So now these two containers are on the same network. They can talk to each other. And this works out great if I've got an API that needs to talk to a database. I can put them on the same network and talk to each other, but I can run another app with its own database and put them on separate networks. And so those two containers can talk to each other, but it allows me to isolate my applications from each other, which is pretty nice to have. So now the question is, going back to my slides here, is, if this demo that I just did was fully IP based. So I had to look up the IP address of the other container and connect to it. So how do I connect to a database, for example, and know where that database is? I don't want to have to go look up the IP address and go from there. Well, there's a good solution to that. Okay. And the solution to that is to leverage what the internet's been using for decades, and that's DNS. Okay. So DNS is the domain name service system, and it provides mappings from names to IP addresses. So when you type in, for example, docker.com and you press enter on your browser's not literally connecting to docker.com. What happens is that there's a DNS request from your machine to a DNS server that responds and say, all right, here's an IP address that you can connect to. Now, these DNS servers can give you different answers in a lot of different ways. So, for example, this was an address I got a couple days ago, but it may be very different than those of you that are watching from the other side of the world. You may get an IP address that's more closely located. So the DNS service can do some like geolocation based on this location. We're going to give you a different answer. But anyway, so my machine got this answer, and then my machine actually talks TCP and IP to 141, 183, 213.20. Okay. But me as a user, I just typed in docker.com, press enter, and it did its magic from there. So, this is a powerful abstraction, this be able to specify just a name, and then DNS says, well, yeah, that name really resolves over here, and goes from there. Well, pretty much every container orchestration framework does the same thing. Okay. And Docker runs its own DNS service in the container networks and makes itself the default DNS resolver. And so what happens is that when a request comes in, it says, hey, can I answer that request? And if not, I'll just go to your an upstream DNS service and let it resolve. And I can also give containers additional network names using the network alias. Okay, so let's actually go back to our demo here. And if I look at this was my Nginx container that's running, we see that one of the aliases that it was giving this is actually the shorter ID of the container. Okay, so I can actually curl HTTP that name. Again, what's happening here is when DNS is resolving, Docker is saying, yeah, there's a container on that network that has this alias, so I'm going to resolve it to that location. And let me actually put the verbose flag on here, and we could see here that it was connecting to 172.18.0.2. And again, because DNS resolved to 172.18.0.2. Okay. And then it sent the request to that container using the container ID's hostname. Now let's do the same thing. Now let's add a network alias of let's see, what's a random thing I could think of. Moby. Okay. Moby, in case you don't know, is the name of the Docker whale. So this time I ran another container on the same network and gave it a network alias of Moby. Okay, so if I inspect one EA8, I'll see now I've got two aliases here. One is still the container ID, and one is now Moby. Okay, so I can curl HTTP Moby. I get my answer. Hooray. Okay, so let's actually jump back to our Play with Docker instance here. And let's get our app to work here. So the app failed to start. Let's create a network. Create network workshop. Docker network. Create workshop. Had those in the wrong order there. And what I'm going to do now is let's run a the workshop network. We're going to give it an alias of Mongo. And we're going to run a Mongo. Let's run it in the background on the Mongo image. Okay, so what this is going to do is it's going to download the Mongo container image. It's going to run it on the workshop network, and it's going to give it an alias of Mongo. And this will take a second just to download and then unpack. So we're extracting the container image right now. Okay, so let me actually maybe go back to the question. So could you explain, if you are building from a previous container, why it's more secure, harder to exploit? So maybe I'll explain that just a little bit. So if you're building from a previous container, so let me clarify. Let's go to VS Code here and boop. Okay. Let's make a new one here. And I'm just going to pick some hypothetical names here. Okay. So imagine that I've got a Java application. So from JDK, and this isn't a valid image, but again, it's just for demonstration here. So I'm going to copy in my source code and put it here, and I'm going to run a Maven package, okay, to build my application. Okay. Now when this runs, let's pretend, okay, let's make a worker of just app. Okay, when this runs, it will output a WAR file at app target app.war. Okay, let's just pretend that that's what happens here. Now, so the question about how this helps make things secure is that in my production environment, when I'm running my application, when I want to run this WAR file, I don't need all the tooling that was needed to actually build the war file. I just need the war file and the ability to execute it. And so in this case, I wanted to start from a JRE, just a runtime. So I don't need the ability to compile. I don't need the Maven tooling. I don't need, Gradle or Ant or whatever other tooling. Um, and again, I'm super abbreviating here. This is okay. So I'm going to copy from build app target war and put it into this directory. And then I'll just say that my default command is Java app war. Okay. Um, again, this is super pseudocode here, but the idea again being that when I build my application, the final container image is going to be whatever your final stage is. Okay, so while it's leveraging this previous stage to do the build, this stage isn't actually when I do my Docker push and push my image to my registry, the layers that were built and created as part of the build, only the final stage is pushed. Okay, so my final image doesn't have the JDK. It doesn't have all my other tooling and everything that was needed to actually build the app. It only has the JRE. And so because that my footprint is much smaller in my production image, I don't have, if somebody were to get a shell into it, they can't, they can't compile Java code without having to go install a JDK. It just makes my final image, one, it's a lot smaller to push and pull. But also two, it's more secure because there are fewer things I don't need in the image. The same thing applies to our React app here, where when I do a yarn install for React apps, it's going to be installing Webpack and just a bunch of other stuff that's needed to build my React app, but I don't need that as my final image. For a lot of applications that I build, we'll tweak this a little bit. If this weren't a MERN stack, if I just wanted to ship just this React app, I would do something like this. So from Nginx Alpine, and I'd say copy from React build, user local app build, user share Nginx HTML. Okay. And then there's maybe a config file in here that I drop in. But I do this quite often where now my final image is just an Nginx. It's just a static web server that's just serving the static content for my React build. Okay. And so again, the idea here is separate the build time dependencies and requirements from your runtime dependencies. If I'm just shipping a React app, I could do it with just Nginx and I can just package it in and ship it out. But in this case, since we're doing a MERN stack, it's going to work. So I'll revert it back here. But hopefully that helps answer the question too. If you got a follow up, feel free to post a follow up for us there. Okay. We'll jump back to our browser here. Mongo's finished pulling, running, it's happy. Its name is Laughing Point Care. Huh. Interesting name. All right. So now at this point, let's try running our application again. We just need to do two things. One, I need to run it on the same network. And then I need to specify the Mongo host. And since I gave it an alias of Mongo, I can say your host is Mongo. Did that work? Seems like it's going slow. Maybe. Okay, there it goes. Okay, so it's attempting to connect the Mongo using the host Mongo. It connected successfully, and it's listed on port 4000. Let's see if we can actually open up the app now. Okay. I think there may just be some slowness going on with this instance right now. But anyway, so we got our app. We see in the console log message that it was able to successfully connect. So this network alias, I was able to say, yeah, connect to a host named Mongo. And by using the network alias, DNS resolved to that container and was able to connect to the Mongo database and go from there. Okay. I'm not sure what's up there. We can figure that out later. But anyways, my application is up and running there. So let's go back to our slides here. Okay. So again, the DNS is super powerful, and pretty much every service discovery mechanism in the cloud native space uses DNS, whether it's service mesh or even in Kubernetes itself. DNS is a super powerful thing to basically say, hey, connect to this name. And then DNS is figuring out, how do I resolve that name to the actual thing that you need to connect to, whether it's a container, whether it's a VM in your on-prem cluster, whatever. Um, DNS is really powerful there. So again, just think of it as it's simply mapping names to IP addresses. Okay. So yeah, we just did that demo there. So one of the things that you're starting to recognize here is that there's a lot of commands, there's a lot of flags, and in order to kind of spin up my environment here, um, actually, I want to jump ahead. Oops, almost accidentally deleted some slides here. If I did. That's all right. Okay. So what happens is that, so when I'm running Docker on my local machine, um, the engine, let's maybe just drop into a terminal here. Okay. Right, so when I run commands here, these commands are actually running against my local machine. Okay, and when I do that, the commands are, one second. I'll find another way that we can do this. Okay, all right. Um, Let me make sure I've got this installed. This will be a fun demo to see. Okay. So when I run Docker PS, what actually happens is that the Docker CLI is basically make an API request to the Docker engine. Okay, and the Docker engine itself then is responsible for responding to those messages and working from there. So, for example, when I do a Docker volume ls or Docker run or Docker ps, whatever, the Docker CLI is making an API call to the Docker engine, and the Docker engine exposes this REST API and actually interacts with the actual engine itself. Yeah, trying to think if I've got a graphic that I can pull in this slide. I'll come back to it. But anyways, so what we'll do here is I'm going to run basically a small little proxy here. What this proxy is going to do is I'm going to run on port 2375, and it's going to forward all the requests to the var run docker sock. Okay. And what I'll do in a split screen here is export docker host equals localhost 2375. So now what happens is that with that environment variable set, with this one set, all my Docker commands are going to go through this proxy, okay, that I'm running, and we could see all the communication that's going on between the CLI and the engine API. And when the proxy receives the request, it's going to just forward it onto the Docker socket and actually make the request against the engine. So, for example, when I do a Docker PS, that was a lot of stuff that came up. Okay, so when I ran the Docker PS, we can see that first a head for a ping was made, just to make sure that it was up and running. And then I see a GET request to say, hey, give me all the containers and JSON output. And then the response from the engine says, okay, here's all your containers. And there's just this big old JSON blob here. And then the CLI takes that JSON and converts it to a CLI based output here. Now, what's cool is I can actually make these same commands directly against the Docker socket myself. So let's just copy this here. So I'm going to curl, and I can use Unix socket equals var run docker.sock. HTTP, it doesn't matter what the host name is. Oops, I got an extra space in there. Oops. My machine doesn't have the right version of curl on it. That's okay. But anyways, so I think this is the default Mac one, and it doesn't have the socket support on it, which is okay. Well, anyways, maybe I can just do it in a Alpine container then. So let's run docker.sock. Add curl. This one, does it have It doesn't have socket support yet. That's okay. Anyways, um, but sockets at the end of the day are another way for network communication. So instead of being on ports where I'm going, localhost 8080 or whatever, um, it's going more to a file. You can think of it as that way. But what it is basically a file-based network connection. So I can curl against that socket, and then the engine who's exposing that socket is listening for requests that come across that socket and provide the response. So we see that here. I could do the same thing now if I say, Docker image ls. This may be super noisy, but I can see, there are all the different images that I have on my machine and a big old JSON blob there. So the key piece to take away here is not okay. How to actually listen to the API. The key piece to take away here is that the Docker engine itself exposes an API, and the CLI is actually interacting with that API. And the big advantage of using APIs is it allows us to build additional tooling that can also hit those APIs. And so Docker Compose is one of those tools. Okay. So Docker Compose provides the ability to define multi-service applications. So this is a multi-service application in a YAML file. Okay. If you're not used to YAML, no worries. It doesn't take long to learn and to get spun up with it. And YAML allows us to kind of define everything. So for example, this particular application here, we've got a backend, we build the backend, we expose some ports, specify environment variable. In many ways, this codifies all the Docker run commands that we were doing before. So, I don't have to specify a bunch of different Docker runs. I don't have to specify, just a lot of different things. It's all just there and ready to go for me, and define a single file. And just like a Docker file, it can be version controlled and put into our repo. There's a link here to the Awesome Compose repo, and let me go ahead and just pull that up here. So Awesome Compose is a repo that's maintained by Docker, and it has a lot of great examples of compose stacks that you can leverage. So there's Flask applications, there's various Nginx and Golang, MySQL, etc. But like for example, if I want to do a MERN stack, there's a compose file for it here as well. Now this is of course is a little opinionated on how the back end and front end are set up and everything, but you can use these as kind of inspiration if you get stuck to know, hey, how do I think about creating my compose file? And there's probably a lot of different things that you can learn from this as well too. So feel free to go through this and try things out. We're doing a lot of work to try to make this more accessible and easier for you to experience and to play with and whatnot too. So expect to see some improvements in this area, but there's a lot of really good things in this Awesome Compose repo as well. Let's see. All right. So Compose and networking. What's cool about Compose is that with when I run Docker Compose up, which we'll do here in just a minute, we'll create a Compose file for our MERN stack we're converting. When we do so, a new network is automatically created for us. Okay. And this network will contain all the services by default, and they can talk to each other. And one additional cool thing is that there's an automatic alias applied for each of the services. So for example, the container for this backend will automatically have an alias called backend. And the container created for this service will automatically have an alias of DB. So theoretically, kind of going back to our other example, if we run a Mongo service and we name it Mongo, well, then the host name will be Mongo. And that's exactly what we'll do here in just a minute. Okay. So again, the networking, we can define volumes. We can basically put everything into a single file and be able to just run Docker Compose up, spin it up, Docker Compose down, tear it all down. So with that, let's go ahead and convert our MERN stack. And so I see a question that just came in. I'll go ahead and answer that actually before we jump in. So Docker Compose is like Helm for Kubernetes or like a K8s manifest file? Sort of. One of the differences is Helm supports templating, and of course you can do variables and template substitutions, conditionals, and that kind of stuff. So think more Helm is a templating language for your manifest, while Compose is going to be a simplified manifest, where it's again, going back to this example here, let me go back a slide. You know, where Kubernetes, this would be split into, okay, in order to deploy this, let's see, I would need, deployments for each of these different services. I would need to create Kubernetes services. So it's split across lots of different manifests. Docker Compose provides me a more succinct, a smaller specification to define my application. So hopefully that makes sense. So they're solving different problems. Compose isn't really designed to be templated. There's not conditional support. You can pass environment variables through, but beyond that, it doesn't have the same templating capabilities that something like Helm does. So hopefully that helped out. Feel free to ask a follow-up question if you like it to. All right, so let's jump to our VS Code. And I think I can save that. All right. What we're going to do is we're going to refresh ourselves real quick and see how we were deploying this, or how we ran this earlier. So remember when we started this off, in order to do development on this application, we had to run Mongo. Then we had to run a yarn install and then run yarn dev. And then we also had to do the same thing for the front end. Okay. We've already updated our deployment because we've created a Docker file. And so we should probably update the README here, but we'll save that for a later time. Now we want to make the development experience much better, much easier here. And so we'll go ahead and containerize this. And the way that we'll do this is I'll create a Docker Compose file. So Docker Compose YAML. And what we're going to do is we're going to start defining our services. So the first thing that we specified that we needed was we need a database. Oops. Okay. And this database, okay, we're going to say, we're going to call it Mongo, and our image is just Mongo. Okay. Now, if we actually wanted to, let's jump to, right, one, I want hub. So this is a Docker official image, and if I look through the documentation here, it provides some kind of best practices on how to use this image. Since I'm just using this for local development, I'm not going to worry about setting ultra secure passwords and all that kind of stuff. But if you want to learn how to do that, it's here in the documentation. But one of the things I do want to do is I want to be able to persist the data. Okay. And I might have just gone by it. Okay, where to store data. Okay. So it tells me that Docker run, it will store its data in the container at /data/db. Okay. So some of the things that I can do, in this case, it's mounting the code onto the host machine. But in this case, I don't really care where it's mounted. I just want to know that the data is persisted. So if I restart my stack, I still have my my application from before, all my state from before. So what I'm going to do here is I'm going to specify volumes, and I'm just going to say Mongo data, and I want that stored at DataDB. Now, so what this is it's basically a named volume that says, hey, I want to create a volume that's named Mongo data, and it's going to be attached here, and whatever gets dropped there, I just want to persist it. I don't care where it's persisted. I just want to know that it's still there. So if I spin this stack back up, I still get all the data. Now, in order to do that, I have to specify Mongo data as a volume. And what will happen now is let's actually go and spin this up. Docker Compose up. I'm going to add a -d to run it in the background. And actually, let's go ahead and remove our containers from previous. And remove our Mongo container from previous. Okay, so now we just have the Mongo container that we just spun up. If we take a look at this container, look at the volume details. There's all the networks, labels, entry points. So we see volumes. Okay, So we can see here are the mount points, and the Mongo data mount point, or the volume. Uh, so when I run compose up, it uses this name as part of the name of the volume that it creates, but it also prefixes it with the directory that I'm in right now by default. And so this is where it's actually physically stored on the Docker host VM. If I do a Docker volume ls, I can see that here. There's the MERN app Mongo data, and it's there. Okay. Um, so I've got Mongo running. Now let's go ahead and add our first service. So if we look at the README here, the next thing that we talked about was starting the backend. Okay, so to run our backend, we use yarn install yarn dev. Okay, so what we need to do is we want to run a container that does this ourselves. Okay, so let's call backend here, image. I'm going to start this off with a kind of naive approach, and then we'll make this a little bit cleaner because we can actually leverage the Docker file, but we'll hold off on a minute. So the command, it told us that we want to do a yarn install and a yarn dev. Now, one of the things that I've learned, especially with node-based applications, is every time I start the stack, I want to make sure that I do a yarn install. And so there's a couple different ways I can do this. I can say yarn install and yarn dev. But one of the things that I actually just like to do is go to my package JSON and update the dev script. Do it here. And so that way I can't start development mode without doing an install. And that makes it so that if I, add a dependency or update a version or something like that, and oops, I forgot to tell everybody to, reinstall their dependencies. Well, the next time they spin up their application, it will automatically do that for them, and there's zero chance that they'll mess that up. Okay. Now, if we're going to be doing development here, we also need to mount in our source code. So let's go ahead and mount in our source code. So we'll say backend, and we're going to put this at user local app. And this runs on, the backend runs on port 4000. And last thing I need to do, actually, let's start there. We'll see an error occur here. Okay. Where's that container come from? Oh, that's from previous attempts. Okay, so let's do a Docker compose logs backend. Now this gives me an error. Can't find a package JSON file in root. And that's because we're telling it, hey, run yarn dev, but it's like, I don't know where you want to run yarn dev. We mounted all of our source code into this directory, but it's trying to run that command at the root. In order to fix that, what we need to do is specify the working directory. Now, what that does is it will run this command in this directory where there is the package JSON, and it should work now. So let's go ahead and restart our stack. And let's look at our logs. And we see it going. So cool thing about Docker Compose, I can say I want to follow the logs for a specific service, and I can add a -f to follow, and then I can watch things go from there. Now we're back to this error that we saw before, attempting to connect the Mongo using host localhost. Okay, so oops, we forgot the environment variable. Let's add that in here. Okay. Mongo host of Mongo. All right. And the cool thing about Docker Compose is I don't have to tear it down every time I make a change. I can just say, hey, spin it up again, and it will do the reconciliation to figure out what's changed and just bounce the containers, or restart the things that I need restarted. So in this case, the Mongo service didn't need to be bounced again, and so it didn't change anything. It said, hey, it's already running, and so we're going to restart the backend service because we added this new environment variable. And now we see that it's successfully connected. Okay. And I can validate that by jumping to localhost 4000. I can say, hey, give me all the to-do list items, and it's just an empty array right now. Okay. Cool. All right, so there's my backend. And what's cool too is I'm using a tool called NodeMon that if I go in, let's just add another route here. App.get workshop. And let's just have it send message of hello world. Since this code is mounted into the container, when I save, you'll see that nodemon saw the file change and will restart the application. And so when I go to my browser, and if I go to workshop, if I spell it right, workshop, now I get my message of hello world. Okay, so this is again one of the advantages of mounting your source code in, because if I put tools in my dev environment that that watch for file changes as I'm saving and making changes, it's going to see those changes and update those. Now, so nodemon is a great tool that I use for node environments, but many other languages and frameworks that you're using have similar mechanisms to be able to do that. Okay, I don't want to actually keep that, so I'll go ahead and remove that. You see that it bounced, and now if I go back to my browser and refresh, I'll get a can't get that because, well, I just removed that endpoint. So it works. All right, back to Docker Compose. I've got my back end there. It's working. And now let's do my client now. So much of the same thing. Node LTS Alpine. And I'm going to do a yarn dev as well. Volumes. Oops. Client user local app. And so one of the things I can do if I wanted to make like yarn installs faster is I can actually say I want to mount the yarn directory to root.yarn. As yarn installs packages, it's actually caching them on your local machine. And so by mounting that in, it can leverage the cache across builds and across installs and all that kind of stuff. So now if I restart the container and if I'm starting from scratch, it can pick up and go from there. So actually to demonstrate that, I'm going to go ahead and delete the node modules directory here. Boop. And we'll see it when we spin it back up. All right. And okay. Docker compose up. Background. Docker compose logs client. Follow here. All right. So this is output from a previous, don't worry about it. But I see error command dev not found. And that's because I'm running yarn dev here, but this particular application doesn't have a dev script defined in package.json. So let's go ahead and do that real quick. And I'm going to follow the same guidance that I shared with you earlier, in which I'm going to do a yarn install and then a yarn start. Okay, so and that basically means that in order for me to run my React app, it has to do the install, and then it will actually start the React script pieces here. So let's go ahead and spin that back up. Client. And now I'll start watching logs again. And you see that it's already fetching. And since I mounted it in on my my local machine cache, the resolving of fetching was super, super fast. And it just still takes a little while to kind of link everything together and get everything set up. But then here in just a moment, okay, so we see that it's starting. So the yarn install is completed, and now it's starting the development server. And I'm gonna get my browser ready for localhost 3000. Okay, so the Webpack completed. If I jump back to my browser, I see my React app, and just to prove that it's working here, if I jump to VS Code, let's tweak something here. So the to-do list card. If I have no items, let's make that super exciting. Lots of exclamation points on it. I hit save. I see the recompile. I jump to my browser and it's already done the hot reload and made it super exciting here. Okay, maybe that's too exciting, so I'm going to remove a couple, hit save, and you see the hot reload. Drop it right in there. So again, with now what we've done is we've created a compose file that allows anybody to leverage this file to spin up their environment. And when I'm done now, all I have to do is Docker compose down, and those containers are no longer running. My app isn't there. And now I can simply update my README to just say something like this. This repo contains a Docker Compose file that allows you to simply run Docker Compose up. Backend is available at HTTP localhost 4000, and the front end is at HTTP localhost 3000. When you're done, simply run Docker Compose down. And so now, for this particular application, the barrier of entry to do development is simply I just have Docker installed and I just run Docker Compose up. And I can watch logs, I can spin things up, I can, whatever else. And it's pretty awesome. Now, so one additional thing, let's add something else here. So there's a cool tool called Mongo Express. Image Mongo Express, in which it runs on port 8081. Okay. Go ahead and spin everything back up. What do I do here? Sorry, prune. All right. And now it's Docker Compose up. I had a name conflict with another network that I had before, and it just got mixed up. Okay. So now I see everything's running. And I don't think I mentioned it earlier, but if I do a logs without specifying a service, it streams all the logs together across all the different services, which is super helpful. Okay, back in my browser, if I go to localhost 3000 now, let's add, finish the workshop, do something amazing. Be awesome. Okay, uplifting to-do items. So this Mongo Express, if I open up localhost 81, oops. Not right there. Let's figure it out. Express. Oh, I think I know what it is. There's a race condition there. Try to spin up before the database was there. Okay. And so now I go back. That's way too zoomed in. So let's zoom out. And so this Mongo Express app is basically just a little GUI to our database. And so I can view the to-do list collection that we're using. I can see here are the items that I just added. So let's go ahead and be awesome. Let's pretend I'm done with being awesome. And so, oops. Mark that as true. I hit save. I go back to my app and refresh, and now it's marked there as well. So this helps show that, okay, now that I've got this compose file, it makes it really easy for me to add additional services, additional tools, additional capabilities. And all I had to do was just say, hey, I added yet another container here. And now with this, I've got a GUI to my Mongo database. So if somebody's not as comfortable dropping to the Mongo CLI, well, cool. Now I can just bundle that as part of my application stack here. And it makes it, again, easier for developers to debug and figure out what's going on with their application. So Compose makes it a lot easier to, all right, now that we've got something going, let's figure out how to make the experience better for all of our developers there. All right. Let's see how we're in time-wise. 35. Okay. So one of the things that I'll just mention is we've got some duplication between our Docker file and then what we're using in our Compose file. And some of this duplication is like, for example, the node, the image that we're using, we've got that defined in the Docker file. It would be great if I'm always using the same version for development versus prod, etc. So I want to make sure that if I didn't pin this to node 16 or node 18 or whatever, Oops, I forgot to update my compose file. Now I've got drift that's going on. Okay. So what I can do is something like this. Um, Rather than specifying image command and working dir, okay, I can say something like this. So let's build an image, and the context is the current directory, and the target is base. What this is saying is rather than using an image that's coming from Docker Hub, I want to build a container image. In this case, I'm going to use the Docker file. So that's what the context is, the current directory. And the target says, yeah, I've got multiple stages here, but rather than using the last stage in my compose file, I'm going to specify I want the base stage. In this case, this allows me to remove the base image as well as the working directory. Okay, so I can remove that. Let's do the same thing. Okay, so that's pretty cool. One of the other things that we can do that we see some duplication with is that I've got, let me scroll back up a little bit. I've got this command that's the same between the two here. So maybe there's a way to fix that a little bit. Okay, so how about this? Let's go back to our Docker file and say from base. So I'm going to start from that base again as dev. So I'm going to make a stage that's really just used for development. So maybe we'll call it development. Okay, and I'm going to specify the default command of yarn dev. Now in my compose file, I can just say my target is dev, and now I don't need to specify the command. And I save this, I save that. Now when I do my Docker compose up, what we'll see is it will change. Oh, whoops. I named that development. Now when I do this, we'll see that it will actually do a build, and it just did it so quick because it's cached and there's not much to build there. But we see that it started up some containers, and everything's running as expected. And again, now the advantage is that my Docker file is my source of truth for what is my base image for both development and my production containers as well. So pretty cool stuff there. All right. Let's see. Let's go ahead and go ahead and commit this. Containerize application. Okay, but I'm gonna put this in a different branch. So that way, if anybody wants to go through this exercise themselves, they can start with the main branch and kind of have the uncontainerized version, and then, okay, how do I switch to the containerized version? How do I go through that process myself? Now, so again, what this allows me to do is let's go ahead and tear all this down. And let's go back to our play with Docker instance here. And remove that. Okay, we've got no containers running. And let's grab my repo, hit clone, cd into that directory, and let's just run Docker compose up. Oops. Oh, yeah, get checkout. All right, let's make sure we're on the branch then. Has the compose file. And now when I do a compose up, it's going to pull down the images. It's going to do the build. It's going to do all the different things that we need to actually run our application here. And again, the true value here is that now I can just simply do a git clone, Docker compose up, and I can start contributing. And I don't have to think about, okay, which stack am I working with? Is it a Node stack? Is it a Java stack? Is it a PHP stack? Is it a Ruby stack? Whatever. The compose file takes care of all that for me. And I can just focus on my code. And as an app developer, I don't have to think about how to set up my machine. And I don't have to think about, okay, when I'm working on this Node application, I'm using these versions of Node. But now if I switch to another Node app, I have to use a different set of versions and dependencies and everything else. It just takes care of all that for me. And okay, so the client is still fetching packages, so we'll give that a minute for it to finish. Our backend is up and running. All right, that's coming. I'll close out some of these tabs here. And in just a second, we'll have the React app front end. I guess while we're waiting on that, we could see that the back end items, it's pulling from the database, which is empty. See, the Mongo Express is there running as well. Let's see, here's our client. Okay, there's the dev server starting up. Bum, bum, bum. And this should be ready to go in just a second. This is when I should have some like background music ready for us, huh? Yeah, I'm not sure what size machine instances these are on. So sometimes doing some of these larger React apps, or even though this isn't really a large React app, but React takes a lot to run. Okay, so now we see that the app is there. I can open up localhost 3000, and we're still getting that same error. We must have messed something up here. Oh, it's because it's hard coded to go to localhost 4000. Okay, so yeah, we'd have to change the URL that it's fetching from. But anyways, the app is there. You can see that it's running and whatnot. I'll have to do a little bit of tweaking to the source code to let it be super flexible, depending on the environment. But it's hard coded right now because it's just meant for local development, proof of concept. The API is expecting to come from localhost. But anyways, again, I can do kind of the same things where I can make changes to the source code. We see that the change is being applied right away, and all the tooling, the database GUI, and everything else is just kind of at your fingertips and is ready to go. So Compose makes that so much easier to leverage and to use. All right, let's jump back to slides here. And for the most part, I just want to kind of recap. We just converted our MERN stack. And so kind of next steps, where to take things from here. Now, up to this point, we've pretty much talked about containers really in the local development experience and how we build containers, how we build with containers, how do we leverage them, and again, compose files make that super easy. So if you're just starting your container journey now and wanting to figure out what your next steps are, the first thing I'll say is this first bullet point. It's a journey. Okay. This cloud native space is huge. There are more tools than I can even imagine. I don't know if you've seen for example, the CNCF landscape. I can pull that up real quick. It's mind-boggling how many tools there are. So the CNCF landscape is a collection of a bunch of different tools and services and open source projects that help you build cloud native applications. And so if you're wanting to learn about scheduling and orchestration, well, here's some containers, or here's some things to look at for scheduling and orchestration. If you want service proxies, here's a lot of different services and proxies. And these don't even have all of these. These are just open source ones that are part of the CNCF landscape. But there's a lot out there, and it's overwhelming. So again, this first bullet point of it's a journey. Don't go crazy with it. Too many times I've seen somebody say, hey, I want to do containers, therefore I must Kubernetes and I must learn everything. I commend you for your efforts, but don't go crazy with it. Take your time and go slowly with it. And the thing I'll say too is just start playing with them. I've worked with a lot of teams that gain value all along the way of their container adoption journey by simply just doing little things along the way. So, for example, if in your environment you're SSHing into a machine to run a deploy script, that's fine. Okay. Maybe the next step is, hey, let's build an application as part of our local development experience. So let's build the image, let's push the image, and then maybe our deploy script, rather than doing whatever it was doing before, maybe it's just doing a Docker run now. Okay. Sure, it's not the full, end automation experience that you may want, but now you've got a reproducible environment in a container image that's going to be the same on your local development machine and your production machine. And you're already getting a lot of value out of that. You can take baby steps, and that's okay. Don't feel like you have to go from containers to full on Kubernetes overnight, because it's not going to happen. Okay. Take your time. But I will say that orchestration is where the power starts to come in. When you use tools like Kubernetes or ECS or Swarm or Nomad, these tools, again, part of the reason I use this picture again is that just like in a container yard, there's lots of software and tool and automation that's grabbing, that knows, that keeps track of containers as they're moving around, et cetera. Much the same happens in our clustered environments. Okay. Kubernetes is keeping track of what containers do I have running where on my 100 node cluster or whatever. And it's keeping track of that for you. And you can start to get a lot more really cool stuff built on top of that. But again, take it with baby steps, and you'll eventually get there. So, feel free to reach out to me. I've got my Twitter handle on, just below my name here. So at MikeSir87. Feel free to reach out to me and let me know how I can help you out. Let me know what questions you might have. Again, as I mentioned earlier, my primary role and job right now is as an engineering manager at Docker. And so one of the things I'm trying to do is figure out, how do we make things easier for people to onboard, to get going, to do development, et cetera. So if you've got questions, if there are things that we can make better, let us know. And always happy to help out. So if we've got any more questions, or if we've got anywhere else that we want to go or dive deeper on, we've got, I guess, about another 10 minutes, and I'm happy to go wherever from here.
No, it's wonderful. Like I really like your energy of being like, we have approaching 2 hour, but I've never been bored. The way you pick up the pace, like is it brilliant? Like you have a very great learning skill, sharing skills with others. Like in teaching Docker, I think it's really tough because when you start thinking about we're talking about some little things, but these little things actually difficult for the beginners to grasp up. And but you takes on the hands-on approach, writing the Docker file on the live stream, and then putting up on the Docker, like the play with Docker playground, and on doing this on the VS Code. I really love that all the things you've done. Big fan right now of your how you taught everything else, and a wonderful, great audience presence in the live stream. So it's been a great session for everyone
Awesome.
to learn. So
Well,
one question, like absolutely, one question one like I like to add here is like, we see like other programming, like other container technologies has this kind of reproducible build concept. Like when you put up the base image container, and later down the road you found out that this base image container has so many CVEs, the common vulnerability exposure. Do we have a leverage to replace this just a base image layer in a Docker file and do all and never change anything else?
yeah, so that's a great question, and a space that's getting quite a bit of work on right now. Um, I'm trying to think if I've got a demo that I could show off of that. So I don't have one prepped yet. So maybe I'll have to come back and visit you again another time. But yes, actually, so one of the newest features in Build Kit allows me in a Docker file to basically say, hey, this layer is kind of independent of previous layers. And so what that means is that if previous layers have been invalidated, the cache has been invalidated, I can still leverage caches for this layer, assuming like files didn't change or that kind of stuff. And so, yeah, it could allow you to say, hey, I want to swap out a base and not actually have to rebuild everything underneath of it. You do have to be careful with it, because a lot of times if you're updating for a CVE or a base image, some of those libraries may change. And so some of your compilation may change, or you may have other downstream effects of that. So you do have to be careful with it. But that is an area that's getting quite a bit of focus and attention right now. So expect more and expect that to become easier over time. It's still a little tricky to use right now. So
Yes, absolutely, absolutely. I can expect those. We have a wonderful Docker team and the wonderful Docker captain in the community. We can expect the great things to happen. We already see a lot of the Docker extensions in the market to help
yeah,
you make more productive with the container land development environment, because you need so many other things aside from Docker, container availability scanning or Sneak or Privy or
yeah,
vCluster. So there are so many good stuff is coming up. And thank you very much. Like, I really enjoyed the way you pace the workshop. I think everybody enjoy it. That's a big part of it. This live stream. Like, I see a wonderful comments during the session. Great question going along the way, and you pace it wonderfully well. So I have seen some of the previous webinars and on the
mhm,
Docker channel, and this is I hope become a very wonderful learning journey for everyone to join us. And for soon it will be available on the YouTube channel. Everybody can watch it again and again. So there are so many good things to learn from the running a Docker, running an app inside a container, to the Docker networking, to the Docker Compose, writing a Docker file, multi-stage Docker file, Docker networking, Docker Hub. We covered a
yeah.
lot.
When you put it that way, yeah, we covered a lot, didn't we? Yeah,
Yes, we covered a lot. Even we covered the compose part like a very wonderfully. Like, we take a Docker file and write the compose back into it, and people let people know that how you can write Docker compose file like a Docker captain.
yeah.
It's been a great learning journey.
Awesome. And
So
maybe one thing I'll just put there too is again, like I said at the end, it's a journey. Okay. And I know, I was showing a lot of kind of best practices along the way and that kind of stuff. Um, but don't feel like you have to get every best practice when you first get started. Start playing with it, start exploring. If your compose file isn't the best, most optimized, to get started with, that's okay. And there's always room for improvement and to keep making things better. So I'm just happy to show off a couple along the way, but there's probably things I miss. So if anybody sees anything that I should do better, feel free to reach out, let me know. I'm always looking on how I can improve myself too.
absolutely. People show interest. Like, one of the comment I'm saying, will there be next session 2 or 2? Like, we definitely do that. Like,
Yeah.
we try to do it again. Like, one of the new thing, like reproducible image or something else coming up. I will tag again Mike Irwin, because I really like his passion, energy of telling people the way you doing this kind of workshop. So it's been a great day for me. Great learning, right? I have learned so much a lot. Been
Good.
working on a Docker for a very long time, but to be honest, I've learned so many new things along the way. Some of the commands you showed up, I have I have seen today, and I will definitely try to practice my own. And there's a GitHub repository available. I will share it with you on the Twitter and LinkedIn account, so you can try out, and you have all the things available for you, so you can try out as many times as you like. So thank you everyone for showing your presence in this Cloud Native Islamabad live stream on Docker 101. And we will be streaming again on the DevOps roadmap with Michael Cade on the this Thursday. So stay tuned for another wonderful workshop. So another good comment. Thank you, Richu, for showing it for a wonderful comment. We will see you again. Thanks everyone. Stay safe, stay healthy. Bye bye, everyone.
Thanks all.